Hello dear friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at a qualitative study of the chain rule of differentiation. Friends, this is a very important rule among all the methods of differentiation that we know, both the ones we've seen and those we are yet to see. So guys, if you're new to this channel, don't forget to press that black subscribe button looking at you friends, and also press the notification icon to get notified each time you load new content guys, and please give it a thumbs up. That goes a long way to motivate me to keep creating more great content for you guys. Thank you very much, and let's dive straight into our video today. Welcome friends. So guys, for the chain rule guys, we want to have two functions. We may call those functions y equal to f of t, where t is a parameter. Then we have next one, we have x to be something like what, h of t. In this case guys, the chain rule is simply saying that our dy by dx will then become dy by dt. That's differentiating the first one with respect to t. We have dy by dt times dt by dx. Friends, it makes sense because this dt can cancel with this one at the bottom, right? So we have dy by dx as what we have. Now friends, we can also say that the chain rule is also saying that dy by dx in this case is therefore the same like dy by dt divided by now the reciprocal of this guy, which is therefore going to what guys, dx by dt. Great. Friends, this is a summary of what the chain rule is simply saying. All the long notes that you've been seeing in your textbook, in your syllabus guys, everything has been summarized just with the definition of the chain rule as we have here on screen. So friends, if you can master what the rule is saying guys, you have studied the entire chain rule completely. All right friends, let's look some examples. By that I believe we are going to understand so well. Let's look at example 1. We have y equal to e raised to the power t, and we have x equal to sine of t. We have the second, we have y equals the natural log of 3t, and we have x equal to 4 times the tangent of t. We have 3, we have y equal to natural log of t, and we have t equal to tangent of x. Keep in mind that in this case guys, t in this case is a function of x, not x being a function of t, as we've seen in these two earlier problems. All right, let's look at the solution guys. Let's look at the solution. We have the first one, y equals e raised to the power t and x equal to sine of t. Guys, let's look at the first one part by part. We have y equals to e raised to the power t, right? We want to get dy by dt. What do we do guys? We differentiate it. So dy by dt guys, keep in mind that e raised to the power t never dies. Okay, yes, e raised to the power t never dies. If you differentiate it 1 million times guys, you still have it. So dy by dt guys gives us what? The same e raised to the power t. Good. Now friends, we need a dx by dt, right? So we're going to differentiate. We're going to have dx. We have dx splitting like what guys? Differentiating sine t gives us what? Cosine of t. Positive guys, positive cosine of t. Great. So guys, now it therefore means that our dy by dx, that is using the second version of the chain rule, dy by dx simply becomes dy by dt, which is what? E raised to the power t, right? Divided by what? Dx by dt, which is what? Cosine of t. So by so doing, we are going to have dy by dx equal to e raised to the power t all over cosine of t. Great. So guys, that's the answer to this problem. That's it. Let's look at the second question. We have y equal to natural log of 3t, x equal to 4 times the tangent of t. Okay guys, let's look at the first. We have y equal to natural log of 3t. Now guys, dy by dt, that's differentiating both sides. We are going to have dy by dt equal to, guys, I told you guys how to differentiate a natural log function, right? So when you do that, you're going to have 1 over t. Great. Now guys, let's now look at x equal to 4 times the tangent of t. Dx by dt gives us what guys? Differentiating tangent gives us what? Sec squared. Okay, so we have sec squared t. The first is a constant, we can put it outside. So we have 4 times the tangent of 4 times sec squared t. Great. That therefore implies guys, using the same procedure, dy by dx becomes what? Dy by dt, which is what? 1 over t, divided by dx by dt, which is what guys? Great, which is 4 sec squared t. So guys, doing that, we are going to have dy by dx equal to just 1 over 4t sec squared t. Great. So guys, this is the answer. Now let's look at the question 3. Question 3 is saying that we have y equal to the natural log of t, and we have t now equal to what? Tangent of x. All right. So friends, don't forget to subscribe to the channel. If you want more great content, guys, please give the video a thumbs up. That goes a long way, guys, to motivate me to keep creating more great content for you. Great. And friends, please share the video out with your friends. By that, you're going to help them to locate our content. Great. All right. Now friends, let's look at the first. We have y equals to the natural log of t. Now differentiating that dy by the s, guys, gives us 1 over t. Great. Now friends, that's dy by dt, sorry guys, dy by dt. Now guys, we have the second, we have now t to be the same, like that's x. We have t is equal to what, guys? Tangent of x. We might need to take the original tan inverse on both sides, or we might decide to differentiate it like it is here, okay? But let's take, if we take the original tan inverse on both sides, by just taking tan inverse of both sides, guys, we are going to have our x to be same like what, guys? Tan inverse of t. At this point now, guys, we have x being a function of t in this case, right? Great. We have x not being a function of t, not t being a function of x. Now guys, dx by dt, that's differentiating x by t, we are going to have what? Differentiating, guys, differentiating tan inverse of t, we all know it, right? I have a video on it. Just check the check the description of this video, guys. You're going to see it there, where I was able to prove it. I started from scratch and I proved that the derivative of tan inverse of x is what, 1 over 1 plus x squared. But in this case, we have t, so it becomes 1 over 1 plus t squared, guys. That therefore implies, guys, dy by dx becomes dy by dt, which is what, 1 over t, divided by dx by dt, which is what, 1 over 1 plus t squared. So doing that, we have dy by dx equal to 1 plus t squared over t. Great. So guys, you might want to simplify by having just t plus 1 over t. That's up to you, okay? But I'm satisfied with this. If I'm teaching you, if you're my student, guys, and you're watching me, keep in mind that I'll be satisfied with this, okay? If I give you in a test, I'll be satisfied with this version. All right, guys, let's look at another version of the chain rule, which is still the same knowledge we'll be applying, but it comes in a different form where you are the one to create this your parametric functions. Let's look at it, guys. Are you ready? Great, I'm ready to. Let's dive in. Great, guys. Great seasons. Now guys, let's look at a case where we have a function such as y equal to f of x all the way to the power n. Great. Where, guys, this n is a constant. That therefore implies, guys, if we let our u to be the function itself, namely f of x, that is the function part, what has been raised to the power n, that therefore implies, guys, du by dx becomes what? F prime of x, right? Great. So we are differentiating u with respect to x, so we have du by dx becomes what? F prime of x. Now in this case, guys, our y now is what, guys? Our y is, what is f of x? It is what? U, right? So we have y equal to u raised to the power n. Now dy by du becomes what, guys? This, we can apply the product the power rule, guys. We simply multiply this our u with n and subtract 1 from the power. We are going to have n u raised to the power n minus 1. Great, guys. Now it therefore means that our dy by dx now simply becomes, as we saw initially, right, though we had but t instead of u, our dy by dx becomes what, guys? Dy by du times du by dx. What is dy by du, guys? It is what? F prime of x. What is du by dx, guys? It is what? It is simply the reciprocal of this function, right? Because this is dy by du. This is okay, this is dy by du, right? We have it ready. Then, guys, du by dx is what we have here, right? F prime of x. Great. All right, guys, let's look at some examples. That therefore implies, guys, if we substitute everything, dy by du is what, guys? Is n u raised to the power n minus 1. Then du by dx is what, guys? F prime of x. Good. So everything now is a function of x. All right, let's look at some examples, guys. Let's take the first one. Differentiate the following functions. We have the first one, we have y equal to x squared plus 3, all that raised to the power 5. Then we have y equal to 4x squared plus 1 raised to the power 12. Then we have the next, guys, we have y equal to x plus sine x raised to the power 24. Then we have the fourth, we have y equal to natural log of x plus tangent of x raised to the power 70. Great. All right, friends, let's take a look at the first one. Let's look at the solution of the first one. All right. So, guys, in this case, as we have a polynomial function raised to some power, guys, maybe it will be good for us to expand, right? It will be good for us to expand and just apply the fact that the derivative of a sum is simply the sum of the derivatives, right? Great. So let's go ahead, guys. No, guys, no, don't do that. Okay, don't do that. It's not so easy to simplify this up to this power, though you can apply the Pascal's triangle, but it's going to be time wastage and wastage of energy. All right. So, guys, as we did here, we're going to let our u to be what? The function that has been squared, the part that has been squared. Namely, we have what? X squared plus 3, right? Good. That therefore implies, guys, du by dx, that's we differentiate u with respect to x as we did here. We are going to have what? 2x, because differentiating 3, guys, gives us 0. Doing that for x squared gives us 2x squared. This is what we have, guys. Therefore implies our y now becomes what? What is x squared plus 3, guys? It is simply our u. So we have y equal to u raised to the power 5, right? Now, differentiating that, we are going to have dy by du, which becomes, applying the product rule as I said here, guys, which is n u raised to the power n minus 1. Our n in this case is 5, so we are going to have 5 multiplies, then u, subtract 1 from the power, you have 5 u raised to the power 4. Great. That therefore implies, guys, our dy by dx now becomes our dy by du, which is what? 5 u raised to the power 4, right? Times what, guys? Times du by dx, which is what? 2x. But friends, what is our u? What's our u? Great. X squared plus 3, right? That therefore implies our dy by dx now becomes 10x into x squared plus 3. Great. Because 2 times 5 gives us 10, so we have 10x coming out. Then u raised to the power 4, we have x squared plus 3 raised to the power 4. Great. So, guys, that's the answer. Hope you found it useful, guys. If you found it useful, like I said, guys, give the video a thumbs up. That goes a long way to motivate me, guys. You don't know how important it is, but it is important to me, guys. Great. All right, let's look at the second question. The second question, guys, we have y equal to x plus sine x raised to the power 24. But friends, maybe I shouldn't solve the second. Okay, maybe I shouldn't solve the second, right? Yeah, because you can apply this same knowledge here. Okay, apply the same knowledge in question 1. Maybe I'll solve question 3 and question 4, okay, because they look somehow complicated. I'm going to handle them. Don't bother. Just use the same approach we used to solve question 1 to solve question 2. They look much alike, right? They're all polynomial functions of known degree powers. Great. All right. So, guys, let's start with this. Let's start with question 3. We have y equal to x plus sine x to the power 24. All right. So, for instance, in this case now, we are going to let our u, as we did, to be what? X plus sine x. Guys, du by dx, as differentiating u with respect to x. Differentiating 1, guys, gives you, differentiating x, right, gives you what? 1. Then if you differentiate sine x, gives you what, guys? Positive the cosine of x. Great. So, guys, now we now have y to be the same like what? U. That is x plus sine x, which is what? U. We have y equals to u raised to the power 24. That therefore implies, guys, dy by du becomes what? Applying the power rule as we know, 2024 u raised to the power this minus 1, we have 2023. Great, friends. By this now, our dy by dx now simply becomes, we plug in everything. Dy by du is what? Is 2024 u raised to the power what? 23, right? Great. Then our du by dx becomes what, guys? Becomes 1 plus cosine of x. Great. That's what we have, friends. So if we plug in everything, if we replace our u, as we know, with what, guys? With x plus sine x, right? We are going to have dy by dx equal to 2024 into x plus sine x to the power 2023 into 1 plus cosine of x. Great. That's it, guys. That's the answer for this our question. Okay, that's the answer, guys. It looks pretty crazy, right? But so cheap, right? It was so easy. Great. So friends, please share the video out with your friends. Okay, share this video out with your friends so that they're going to join us in this channel. Guys, this is Humble Mark Academy. Great. All right, let's look at question 4, guys. Question 4 wants us to differentiate y equals the natural log of x plus tangent of x all the way to the power 70. Oops, wait, this is somebody's h, right? All right, so guys, without wasting time, we are going to let our u to be the natural log of x plus tangent of x. That therefore implies, guys, du by dx becomes, we differentiate term wise, differentiate natural logarithm of x, guys, we have for 1 over x. Doing that for tangent of x, we have sec squared of x. Great. All right, that therefore implies our y now becomes what, guys? U is a power 70. In this case now, friends, dy by du becomes what? Applying the power rule, we have 70 u is a power 69. Great. That therefore implies, guys, our dy by the x now simply becomes, we simply plug in everything, guys, which is, we have dy by du, which is what? 70 u is a power 69. But what's u, friends? Natural log of x plus tan x, right? So we have it here. Then into our du by dx, which is what we did initially, 1 over x plus sec squared x. Okay, great. That's what we have it here, friends. Friends, I hope you found the content useful. I hope you found it so useful, guys. If you found it useful, please give the video a very huge thumbs up, guys. A very huge thumbs up. And if you have not subscribed, guys, if you're watching my video for the first time or you have been watching without subscribing, guys, you've been missing a lot. Okay, just press the subscribe button and turn on your bell icon to get notified each time you upload new videos. Thank you so much, guys, and have a blessed day.